Hello friends, I am Manish Gupta. Today I am going to talk about Introduction to Business Analytics. Business analytics is actually also known as machine learning, artificial intelligence, big data analytics, AI, ML in short, and so on. So all of these things actually used to mean different things at different points of time. But right now, if somebody is working on business analytics, is more or less same as somebody is working on machine learning and so on. So all these things have more or less become very common in that sense, right? In general, what is business analytics? So as Thomas said, business analytics can be defined as the broad use of data and quantitative analysis for decision making within organizations. So in short, business analytics is all about taking your data, large amounts of data which is available all around, and then gain some insights, gain some knowledge out of it, such that it can be used for actionable insights within an organization. So essentially the question that one asks when they are sort of doing business analytics is, how do I make use of the huge amount of data that I'm collecting so as to drive profits, so as to make my business processes more and more efficient, more and more effective. Okay, so let's get started. And the agenda for this particular talk is the following. It's a four-part thing: descriptive analytics, predictive analytics, and prescriptive analytics. The distinction between these, right, and how the world is moving from descriptive analytics to predictive and prescriptive, right. Next, we'll move to important components as part of big data analytics, right. Next, we'll talk about some challenges, and the last one is, I think, very important for everyone: tips on career in data science. Right. So, what all you should do, both before getting into data science as well as after you are into data science and you're working in, as part of your job. So, what all kind of things make good sense? Okay. So, let's get started. Okay. Let's start by talking about this distinction between different types of analytics, right? Now, there's a lot on this slide, and this slide sort of tells us how there is a very large amount of data that is getting generated. Okay, so here you will see that within 60 seconds, actually, there are about 1 lakh Skype calls that happen. There are about 3 lakh Facebook status updates that happen, right? About 204 million emails get sent, right? That's the huge amount of data that is being generated every minute, right? So, so no wonder the big data has the following different properties: huge volume, and it also has huge variety. As you can see, there are emails, there are user interactions, there are Skype calls, whatnot. So this variety, not just in terms of media, so not just like there is text, there is image, there is video, but also within text there's a huge lot of variety, right? Besides that, there is velocity, of course. I mean, it's not just that there is static large amount of data, it's just getting generated massively. Per minute you're getting more and more data, right? And then there are also issues with respect to value and veracity. So not all data is equally valuable. So figuring out what is more valuable from this large pool of data is a challenge. Veracity is another challenge. Given that there is so much of data, is a good problem to have, but then the bigger bad problem is that you have to figure out whether it is truthful or not, whether it's a rumor or actually it's a real thing, right? So that's the era that we are living in. It's a data science era. We are living in an era where there is huge amounts of data, right? So data has existed for quite some time, and people have been making use of this raw data so as to come up with some descriptive statistics so far. Okay, so all that stuff that you do in Excel is basically this, descriptive statistics. So essentially, if I own a supermarket, say the Moore store, right? So from that supermarket, every day, or rather every second, a transaction happens where a customer just swipes their credit card and pays for a bill, right? So a transaction basically contains a whole bunch of information about the customer, information about what products were bought, what rate they were bought at, overall, and then at the background, of course, there are calculations at how much profit did the supermarket make. Okay. Now at the end of the day, the store manager really wants to know how much overall profit they made, right? Or at the end of the month, they want to know which particular stores in the entire city made more profit. Those are all descriptive statistics questions. Those questions are about summarizing the data using, say, typical Excel methods like like building pivot tables, like doing summaries and so on. Okay. But the world has moved significantly beyond that, right? And therefore we have things like diagnostic, predictive, and prescriptive analytics, right? So what is diagnostic analytics? Diagnostic analytics is about, something happened, but why did it happen? Figuring out why a particular event happened, okay? So for example, there are say 5 stores of a particular supermarket in the entire city, okay? 4 of those stores are making super profit, right? In the last month they made a huge profit. 1 of them did not. You need to know why. Okay. So, or there could be a store which has been making a profit for quite a few months, and then suddenly the sales have decreased, profit has decreased suddenly this month. Why? Okay. To answer those questions is a part of what is known as diagnostic analytics. Okay. Now moving ahead, there is this predictive and prescriptive analytics, and as you see, as we move ahead, analytics is maturing. So we are moving from data to information, information to knowledge, knowledge to insight, and then from that insight gaining something that is actionable. What is it that I can get from this insight and use it to drive profits in my business, right? And that's what we call as actionable insights finally. Okay. So we have covered diagnostic already. Now moving on to predictive, right? Predictive is all about answering what will happen, when will it happen in the future, and so on. Okay, so it's about future predictions, right? So now, for example, the store manager wants to know how much inventory should he keep for various kinds of products. Now for that, he needs to surely predict the demand for each of those products in the future, right? So such predictions are what are studied under predictive analytics. It's not just about the store manager, right? A farmer wants to predict when will it rain. A patient wants to predict how successful his surgery would be, and so on, right? So there are many applications which we'll see in this entire course. In fact, the entire course is going to focus on these 2 parts, predictive and prescriptive, right? And we'll see how to do predictive analytics, right? Now, once you have done predictive analytics, you can actually make prescriptions based on those predictions. For example, given a patient and his current situation, you can predict whether medicines A, B, C, which of them will work what way. So you can basically say, oh, medicine A will actually make sure that you get treated within 1 minute. Not 1 minute. Medicine A will make sure that you can get well within a day. Right? Medicine B is probably expensive, and it may or may not work. In fact, predictive analytics might tell us that it may not be very effective. Right? While medicine C is not very expensive, and the treatment is pretty quick. So now the predictive analytics will just tell you the predictions based on, for this disease, for this patient, you give this medicine, what will happen. Okay. Prescriptive analytics is more like a wrapper on top of that, which basically says out of the various candidate medicines, which is the one that should be recommended to this person based on the predictions that I can make about it. Right. So a whole bunch of this predictive and prescriptive analytics depends on experience from the past. So if you have basically seen many other such cases, for example, this is what lawyers do actually, right? So when they fight cases in the court, they try to relate the current case with the past 10 cases that come to mind which are very similar. And then they essentially choose the next argument such that that argument has really worked successfully in those previous 10 cases, right? And that's what pretty much, very similar knowledge is used when doing predictive analytics and then prescriptive on top of that. Okay. So to do all this, there are 4 important levers that you need to care about, right? Data, tools and technology, advanced analytics, and then domain knowledge. Okay. So data science, or in general big data analytics, has become a norm across industries, various domains. So you may not know anything about that domain, but hey, you can still make significant contributions in that domain using your data science knowledge, right? That said, domain knowledge, if you have that, you can actually make significant progress already, right? Now, what is domain knowledge? Domain knowledge is functional knowledge about that domain. So, and what do I mean by domain? Domain are things like healthcare, finance, banking, insurance, fashion, agriculture, education. All those are different domains. And you know what? I mean, there are applications all across. So there are applications in all of those domains for machine learning and data science, right? So it will be really helpful if you know somewhat about healthcare, if you want to apply data science into healthcare, right? But that said, if you know data science, it is not very difficult to catch up on the functional knowledge, okay? So that's that. And organizational practices. So if you have to apply a particular machine learning or a data science tool to a particular domain and in a particular organization, you rather know what kind of things happen in an organization, what is allowed, what is not allowed, what makes sense intuitively and what not, and so on. Okay? So that's the domain knowledge piece that one needs to know. Right? The next one is advanced analytics. So this piece basically is algorithmic in nature. Here is where different machine learning methods are studied. Okay? So essentially you need to know a few methods like classification, regression, prediction, optimization, what all those things mean. Okay? And that is what the aim of this entire course is. We need to focus on this and basically tell you, hey, how this lever really works. At the end of this course, hopefully you will be very, very advanced in using this lever. Right? The next one is essentially data. Okay? So wherever you go out and work, okay, so you need to essentially work on some data. Every data scientist needs data to work on. Right? Now if you're working in a jobs company like Naukri.com, you will have job descriptions, resumes at the data sets to work with. Right? If you're working in on YouTube.com, you'll have a lot of videos to work with, and you need to do video analytics in that sense. Right? So whatever is the domain, if you're in healthcare, you need to have data from hospitals to work on. So whatever is the domain, you need a lot of internal data. Okay? Now it turns out that more and more organizations are realizing the power of external data. And what do I mean by external data? External data is data on the web. Okay? So it could be general websites, or it could be social media data. Okay? So for example, in healthcare, if I want to sort of, if I'm a pharma company and I'm making drugs, right? Of course, a pharma company goes over years and years of rigorous process before launching a drug in the market. That said, there could be some unintended side effects of the drug. Now, oftentimes patients are very cautious, or they don't want to come out and talk directly to the doctor about those side effects. Many times they put it up on Twitter. Okay? And that is how this external data in form of tweets can be actually very useful for the healthcare industry. In fact, this thing is termed as pharmacovigilance. Okay? So that is how, when you're working in a particular domain, still out of internal data as well as external data. External data is not out of domain data, but out of your organization. Data which is externally publicly available. These both kinds of data make sense. Right? Lastly, one needs to know about tools and technology. Right? Great that you know these algorithms very well, but how do you really code them up very quickly? Right? So that is why you need these data tools. So you need to learn R, you need to learn Python, so as to be able to actually code all of these algorithms and then make use of this data and domain knowledge that you have, run these algorithms on this data. Now to run these algorithms, you need to know how to code. Right? And that is where data tools and the statistical software like R and Python become really handy. Okay. Once you have coded up a solution, of course you want to ship that solution to the customer such that the customer makes use of it and so on. Okay. But before you go and pitch this solution to a customer, you need to be able to tell good stories, because anything does not sell with nothing sells without good stories. Right? So to tell good stories, what you need is visualization tools. Fortunately, beyond typical charts that you can draw in Excel, there have been super awesome visualization softwares which allow you to come up with very nice visualizations, capturing the essence of what you want to present very, very nicely. Okay? Such tools include Power BI, Tableau, and the like. Right? And we will also look at visualization tools a little bit as part of this course. Okay. Lastly, data, we have lots of data, right? And this lots of data cannot sit on a single machine and be processed on a single machine. One has to move beyond single machine and make use of a large set of machines, hundreds of machines, sometimes even thousands of machines. And that is doable only because there are these big data platforms that allow you to scale. So essentially, if you have, say, like thousands of machines and you have like a 1 terabyte of data on which you want to do some processes, how can you do that? You can do that only because some people have invested and built these big data platforms. And that's why it's also an important tool to learn as part of the